Welcome to this video from the RC Ground School. We've discussed the other two important components to your electric model's power system already. Those were the motor and ESC and propeller. In this video, we'll take a quick look at the fuel your model requires to operate. By this, of course, I mean the battery. Most power system batteries are lithium polymer batteries, or LiPos. These batteries are made from strips of anode, cathode, and a separator material that are often folded in a Z pattern to make a stack. This stack is placed in an aluminum sack that has a polymer coating. With LiPo batteries, each stack or cell produces a nominal 3.7 volts. That's why RC batteries increase 3.7 volts per cell when wired in series. When fully charged, they're more like 4.2 volts, but 3.7 is the published value. That means a 2-cell battery has 7.4 volts. A 3-cell has 11.1 volts, and a 4-cell battery has 14.4 volts, and so on. The physical size of a LiPo battery cell changes with capacity while the cell's voltage stays the same. Receiver and other subsystems sometimes use other battery chemistries. These batteries are sometimes nickel metal hydride, lithium iron phosphate or LiPh batteries, or A123 type batteries. For powering your electric model, though, LiPos are what's used. Let's take a look at why that is. First and most important is that LiPo batteries provide high power density and many charge cycles. That means that the amount of electricity available per ounce of weight is high, and they can be charged over and over again. LiPo batteries also come in a wide variety of sizes, capacities, and voltages. This allows you or the model's designer to choose exactly the right size battery to meet the need. LiPo batteries are also powerful and safe when used with care. However, they can be dangerous when mistreated. For example, LiPo batteries can burn when their aluminum pouches are punctured or if they are overcharged. Let's review some charging safety items we mentioned in an earlier video. First, use only battery chargers or multi-chemistry chargers set to their LiPo settings. Next, charge batteries based on their capacity. For example, charge a 2200 milliamp hour battery at 2.2 amps. That's referred to as charging at 1C. Next, charge LiPo batteries in charging bags or boxes. Fire-resistant bags are available at retailers, and boxes can be purchased or made from surplus ammo cans. Charging faults or errors are probably the biggest cause of LiPo battery fires. It's important to charge a LiPo battery with a LiPo charger or on LiPo settings and make sure that the charge settings are correct. Cars and houses have been destroyed due to LiPo fires. Last, supervise LiPo battery charging. That means be close to deal with any possible battery venting or fire. LiPo batteries must also be used within their limitations. Not only can overcharging hurt a LiPo, so can over-discharging. A battery will do its best to provide all the power that's being asked of it. If the circuit that includes your ESC, motor, and prop demands 100 amps, the battery will try to supply 100 amps. Unfortunately, the battery may not be engineered to provide that kind of amperage. It's up to you to supply a battery that can handle the load. You can estimate the max amp discharge rate with this formula: battery C rating times milliamp hour divided by 1000 equals max amps. Since battery C ratings are often very generous, plan to use 2/3 to 3/4 of this rating for normal flying. So, for example, what is the max amp rating and normal planned amp use for a 4-cell 40C 2200 milliamp hour LiPo battery? Let's use the formula. Max amps equals 40 times 2200 divided by 1000, which equals 88 amps. Normal use equals 2/3 to 3/4 of that, or 58 to 66 amps. A battery should not be hot after flight. If it is, replace it with a battery with a higher C rating, milliamp hour capacity, or reduce the load, which for us is the prop size. Crashes can also damage LiPo batteries. Bent or crushed batteries should be safely discharged and disposed of. Don't be tempted to fly with damaged batteries. Internal electrical shorts can be big trouble. If a crash causes the battery's pouch to rupture, contact with the air will cause the battery's internal materials to catch fire. Similarly, if overcharged, internal gas pressure can cause the pouch to rupture. Again, a fire will result. LiPo fires can only be put out with special fire extinguishers, so don't expect to put it out. You'll mainly be interested in keeping the materials around the battery from catching fire. Fortunately, batteries in the sizes used in RC airplanes won't take long to burn out, usually less than a minute. As with any useful, powerful tool, you need to understand how to use it safely. In our last topic, we'll chat a bit about hobby accessories and gadgets. As we close this video out, if you found it helpful, please click on the thumbs up icon and subscribe to the RCPlaneviews.com channel. Click the bell icon to be notified when I post new videos. Thanks for watching.